Precalculus, lesson 11.5. This is conditional probability. So we're at 11.5, conditional probability. So conditional probability has some kind of, as the name implies, condition applied to it. Oftentimes it's represented as an if kind of statement or a given that kind of statement. So a basic example, and then we'll look at two different ways that you can approach doing these kinds of problems. So let's say we have a group, GR, a group of, I don't know, 4 women and 3 men. We can find something like this. Find probability of, well, before I do that, so I'll put it this. Find the probability of randomly choosing 2 people and the second person is a woman, given that the first was we'll go man, was a man. All right, so something like that. So we have some kind of condition. The condition is we are assuming that the condition has happened or will happen. And in particular, we are assuming that you randomly selected the first person and that person was a man. Okay? And then now that a man has been selected from the group, we are looking at what is the probability that now that that has happened, that we select a woman. So we can look at this kind of as the formula way. The formula way would be of P of, and this would be A given B is what that is like. And what it is this P of A intersection B divided by P of B. In other words, what we do is we find the probability that both things happen. In this case, we find the probability. So the B is the condition. B is the condition. So this is given, and then B is the condition. So this would be like find the probability. So for this one, it would be P of woman chosen, second, given man chosen first. Okay. So then how we would calculate that is the P of A intersection B would be find the probability that both of those things happened. So that would be, well, if we assume that a man was chosen first, what's the probability of that happening? Well, there are 3 out of the 7 people are men, so that would be 3/7 times. Well, now what do we have? We have 6 people left. 4 of them are women, right? So 4/6. And we divide that by the probability of the condition happening. What was the probability of the condition? 3/7. So notice what happens is those cancel, and we're left with 2/3, or 4/6 reduced. Okay. So the other way of doing this, that's just kind of the formula way, And what happens is by dividing by the conditional, what you're left with is just the that probability that A happens after B has already been assumed to have happened. The other way is like assume B has happened, This reduces / limits the scenario. Now find P of A. And so that would be like, for this one, that would be like, take the group of 7 people. So say after, so for example, after B happens, we now have 4 women and 2 men. Now we just analyze what's the probability of selecting a woman. Well, 4/6. So I'll say P of A is now 4/6, which is, again, our 2/3. So it's kind of 2 different ways of looking at this problem. Find the probability of A and B happening, then divide that by the probability of just B happening, or limit your focus to only what's left after B has already happened, and then just find the probability. So I have 3 sample problems for us to work through, all from the textbook. First one I have is number 15. And what do we have here? We have a city council, 6 Democrats, 2 of whom are women. So I have city council. We have 6 Democrats. That should be capitalized. 2 of whom are women. 2 of whom are women. And then also on this city council are 6 Republicans. 6 Republicans. And what are we told here? 4 of whom are men. 4 of whom are men. And we want to find P of, it says, a member is chosen at random. If the member chosen is a man, what is the probability that he is a Democrat? So if he is a man, so that's the conditional. So then what we're finding is what's the probability that he's a Democrat given that he is a man? What's the probability he's a Democrat given that he is a man? Okay. Well, let's see what we have. So we want to find the probability of selecting a male Democrat. That would be our numerator, our P of A intersection B. We want to find the probability that both of these things are met. It's a Democrat and a man. So we need to see how many male Democrats are there. The number of male Democrats are, so 2 of whom are women, so 4 male Democrats. These are the male Democrats. Out of the total size of the group, which is 12 people, and we're going to divide that by, let's say total group. We're going to divide that by the conditional, the probability of selecting a man out of the group. So 4, 8, so there are 8 men. Total of 8 men out of the total group size of 12. So then this becomes 4/12 times 12/8. The 12s cancel, and you're left with 1/2. Okay? So if a man is chosen, there's a 50-50 chance that he is a Democrat. is what's going on there. Next example. This one is number 21. And what we have here is we have a standard deck of playing cards. The condition is that the card is black. So the condition is that the card is black. Okay. So the number 21 is find P of 4. We want to find the probability of selecting a 4. Well, if you want the formula direction, we'd ask ourselves how many black 4s are there in a deck of cards? How many black 4s, because that's both conditions being met, black and 4. Well, there are 2 black 4s. There's the 4 of clubs and the 4 of spades. So 2 out of 52 is the probability there. And then what's the probability of the condition that we get a black card in general? That's half of the deck. Half of the deck. So then that becomes 2 over 52 times 1 half. No, divided by 1 half is times 2. Times 2 over 1. So that becomes 4 out of 52, which is 1/13. The other way of looking at it is, other way, I'm gonna say kind of like, or, how many black cards? Well, half the deck is black, so that would be 26. And then how many, I'll say now, how many, I'll say no, instead of now, how many, I'll say now, P of 4. Well, there are 2 of them, so 2/26, which is our 1/13. All right, and one more example. And this is number 33. Number 33, we have a homeroom where 60% of the students have brown hair. 60% of students have brown hair. Okay, what else are we told? 30% have brown eyes. And 10% have both brown hair and eyes. 10% brown hair and eyes. Okay, so that's what we know. Now, I like this kind of situation. I think it can be helpful to do a Venn diagram kind of a thing. So if we just did a rough thing like this, how I would set it up is I would just put the numbers. I would assume like we have 100 people is kind of what I would assume, just to make the numbers easy. So we have 2 circles. We have a big circle for the hair, a smaller circle for the eyes. So this is brown hair. This is brown eyes. And 10 people are in this overlap. So if there were a total of 60 that have brown hair, then that leaves 50 that have brown hair but not brown eyes. And then if there were a total of 30% with brown eyes and 10 of those have brown hair and eyes, then we'd have 20 here that have only brown eyes but not brown hair. So then the problem asks us to find, we're told if the student has brown eyes, what is the probability the student does not have brown hair? So we want to find, no, number 33, number 33. If the student has brown hair, what is the probability that the student also has brown eyes? So P of brown eyes given the condition that the student does have brown hair. Brown hair. So the two ways that you could do this is the calculation way. You could say P of brown eyes given brown hair equals. So on top, we'll go what percentage has brown eyes and brown hair. Well, that's 10%. And then the denominator would be the percent that is a condition, brown hair. Brown hair was a total of 60%. And that becomes 1/6. The other way of doing it would be look at just your condition, brown hair. So we look at this brown hair circle, okay? And we say, if we just look at the brown hair circle, what's the chance that the person has brown eyes? Well, those 10 have brown eyes out of the total of 60, which also gives you that 1/6. Okay? So those are the three examples I have for you for lesson 5. Then I want to give just a little bird's eye view at lesson 6. It's the binomial theorem and probability. So you might recall the binomial theorem being the, no, this is 13.6, binomial theorem. You might recall the binomial theorem being the thing that allows us to, do x plus y to some power and a tool for expanding it. And what it can be used for is it can be used for situations where you can say that there are only two possible outcomes to a situation. It's like either the tree lives or the tree dies. Either you get the question right or you get the question wrong. So an example would be like this. Um, let's just say we have, I'll go with 6 questions. 6 questions that are 4 option, multiple choice. Okay? And we want to find, let's see, we'll say you guess at random. Find, say, P of at least 4 questions correct. Correct. Okay. So then here's how you can set it up. You can say, well, let x equal prob of getting a question correct. So what would that be? That would be 1/4, right? Because there are 4 questions you're guessing at random. And we'll let y be the probability of getting a question wrong. And so what's that? 3/4. So then what we want to find is there are 6 questions. So what we're dealing with here, is an x plus y to the 6th situation. And what we care about is we care about the terms where they get all of the questions correct. So that'd be your x to the 6th term, or 5 questions right and 1 wrong. That would be your x to the 5th y term, or 4 questions right and 2 wrong. So we want to find our x to the 6th plus our 6 x to the 5th y plus r. I just remember that your first coefficient is always 1, your second coefficient is always whatever the exponent is that you're dealing with overall. And then after that, I go, it's 6 factorial divided by the 2 different exponents. So this would be 4 factorial, 2 factorial, x to the fourth y squared. That would be getting 4 questions correct and 2 wrong. Now we plug in the percentages or the probabilities. So this would be a 1/4 to the sixth plus 6 times 1/4 to the fifth times 3/4 plus, what is that? 6 factorial, 6 factorial divided by 4 factorial and divided by 2, that's 15, plus 15 times 1/4 to the fourth times 3/4 squared. And we do our 0.25 to the sixth plus 6 times 0.25 to the fifth times 0.75 plus 15 times 0.25 to the fourth times 0.75 squared. And we get a total of 77 over 2048, which is approximately 0.0376, or we have a 3.76% chance. So yeah, you have a less than a 4% chance of getting at least a D if you guess randomly in that situation. So that's the probability application of the binomial theorem that could be very handy sometimes. And that wraps it up for this chapter. So I'll have a few homework problems for you to do from lesson 5. I'm not going to have anything for you to do from lesson 6. And then later on this week, we will do our first lesson from chapter 15, which should be lesson 15.2. Okay, see you next time.